Hey guys, it's Vince. Today in this video I'm going to discuss the proper method to use when assembling your CNC. Now when I say assembling your CNC, I don't care if you're screwing it together, I don't care if you're mounting stepper motors. This process is virtually the same for anything mechanical that you expect to have precision with. I know what a lot of you are thinking. I don't need to watch this video. I've been turning screws since I was a sperm. I understand the whole concept of the mechanical fastener. Well, I really hope 99.9% of you stay tuned to the end, because I find that in every video there's something to learn. Some things you may discard because you feel you already have the concept of, but some things you will learn. And whenever someone's willing to give you free knowledge and hopefully save you time and money, it always makes sense to stay to the end and see what you can use. So I hope you do that. So now that I said that, just so you all know as well, the reason that I'm doing this video in retrospect is because I received a message from a past client of mine who was assembling his new chassis and actually fractured one of my 600-ounce stepper motors. Now guys, when I say he fractured the motor, he actually fractured the motor mount on the motor, not on the chassis itself. He was using stainless mounts. Those didn't fracture. He tightened down the motor, and as he was tightening down the fastener, it actually snapped the mount that's actually integrated into the motor itself. So once again, this video is imperative. I hope it really teaches you something, and I hope it saves you some time and money. So I'm going to jump right in, give you guys a lowdown of what I did here. I do graphics as well as CNC because virtually it's the same thing, and luckily I have my graphic software open here. I wanted to give you guys a good image of what we're dealing with here because I think it's really an easier pattern to follow. You can use this once again regardless of where you're at. Again, this is a mechanical principle that works anytime you're trying to assemble more than 2 bolts. This mechanical principle works excellently, okay? Especially in a 4-bolt pattern, which all stepper mounts are. Now, what I will say here is you're going to require some tools to actually fabricate your CNC. And when I say tools, you guys already know that being a machinist is not cheap. I'm not going to even claim it is. To do it right is not cheap. But once again, you're building a robot. Okay, and most of you are building a robot maybe for hobby now, but eventually will be for business. So take that into consideration when I start discussing tools and costs, because again, this is what you're doing and you're trying to build a precise machine. So that being said, right here we've got torque 12 to 14 inch-pounds. Now that's for a metal substrate, guys. If your chassis is made out of aluminum or steel, you're going to be fine with that torque rating. If a guy is watching this and he has a wood chassis, please turn the video off, because this video is really designed around guys that are using non-hobby machines, non-homemade, wood-crafted machines, and I'm not insulting your capability of manufacturing one. What I'm insulting is the fact that you're trying to make a precise machine with substrates that flex and give based on temperature. So what we're trying to do here is really keep it as precise as possible, and while aluminum and other metals may flex, they certainly don't flex near as much as wood, and we all know Loctite does not work with wood, especially when you're screwing screws into it. So let's just take that into consideration as I cover the basics here. Once again, the first tool you guys are going to want is a torque screwdriver or a torque wrench. Really, it's regardless of whichever one you want to use, but you do want it to be accurate, and you want to start with a torque of 12 to 14 inch-pounds. That's my recommendation, once again, based on a metal substrate chassis. Torque following pattern is going to be 1, 2, 3, and then 4. We always do the cross-hash pattern whenever there's 4 bolts, because we want to distribute all of that tension and force evenly. Okay, now guys, when I say distribute all of that tension and force evenly, we want to take into consideration that any time you're bolting in anything where there's 4 bolts mounted, if you put more torque on one side than the other, it creates an imbalance that will damage components. Okay, I mean, it'll damage components either now or later. And when I say later, it'll usually be based on vibration induced from the machine. Again, the machine will have stress on it when it's fully assembled, so take that into consideration. That's why, once again, following a torque measurement pattern across the entire pattern of mount will help you guys understand that that machine is balanced. We want to keep this motor mounted and balanced the whole time, as close to possible, all the way through, so that we know that pressure on that motor is even. We want it to keep it as evenly distributed as possible. So that being said, again, torque following pattern, we're going to start on 1, we're going to go to 2, we're going to go to 3, we're going to go to 4. Very simple, very simple. Before we do that, though, before you say, okay, I've got one done, I'm going to go to two, take into consideration that you want to hand tighten down every bolt by using your hand first. Always, always, always use your hand first. You never ever want to engage a bolt using a tool where you would probably put torque on it. If it's not threaded in properly, you could cross thread, you could have all kinds of problems. What I like to do myself is start by hand, of course, and I'll start and I'll go in slightly, a couple millimeters, and then I'll back out initially a couple millimeters until I feel that that screw is in perfectly. This way the screw self-centers itself inside the hole, and then you'll just naturally go in, and you want to do it by hand until that screw literally bottoms out on whatever spacing mount system you're using. Once again, I'm going to reinstate what I just said. You want that screw to be hand tightened until it engages both the back of the stepper mount and also the standoff mount from your chassis. So once that bolt is up against the back end of your stepper and the head is there, then you would then do the same process over to bolt number 2 and move to bolt number 3 and move to bolt number 4. Okay? But before we even start to do any of this, you guys are going to get yourself some socket head cap screws. Socket head caps are truthfully probably some of the best screws invented when it comes to distributing torque evenly. We want to make sure that the torque that's being distributed, even when you use a wrench, is going to allow the amount of torque required and to be as snug as possible. Again, these are the bolts I recommend. It's totally up to you. You can go metric, you can go standard. It's just, again, it's up to the end user and it's up to your chassis really of what you want to do. The big thing here is that you definitely on every bolt on your CNC want to use Loctite 242. 242 is Loctite that's able to be removed with hand tools. They do have other versions of Loctite which are permanent. You're never ever looking at anything permanent. The proper way to use Loctite is to make sure that your threads on your screws are always degreased. That means using a chemical degreaser, and I prefer acetone. It's readily available. And again, if your wife has nail polish remover, it works great. But again, the screws must be oil-free for that component to work excellently. And what it basically does is it fills the screw with a nylon-based additive that once installed in the thread pattern of the hole, it dries into it and it actually then creates more resistance so the bolts don't vibrate loose, which we all know vibration is a culprit on anything you're building that's precision, where again most guys are using large spindles, some of them in excess of 3 horsepower. There will be vibration. So again, this should be used on every bolt. It should be used the same process on every part of your CNC. You can use this torque rating virtually on all parts of your CNC. Okay, as you're assembling it, we're not looking to, again, you're using aluminum, so it's a softer substrate. It is metal, but it is softer. You're not looking at just bare, ham-fisting things, so to speak, and tightening down things to where you're basically either stripping threads or any of that. You don't want to get into over-threading anything, and this is a really nice torque rating. It's going to give you a firm pattern, and again, use your own judgment. If you feel 10 inch-pounds is sufficient, you can do that. As long as you're using Loctite and you've prepped the screws properly, cleaning the threads with acetone prior to assembly, you're going to be set. You get yourself a good torque wrench, a good torque screwdriver, you're going to save yourself a lot of headaches, my friend, and I mean that overall. It will definitely help you. Again, following the torque pattern 1, 2, 3, 4. This is based on only if you have multiple screw holes. Okay, if you have a 3-bolt pattern, you would always start at 3 or 4, whichever one you want. You can go here to here or here to here. Once again, we always want to bottom out our screws by hand first to the back of the mount, whatever you're actually mounting, and also have it to the back of the mount that's actually off of the chassis. So if there's any standoff, you want to be completely flush to the standoff and completely flush to the back of whatever component you're mounting to. And the reason we want that is so that everything is bottomed out. So when you're torquing it down, you're basically just snugging everything in and you're good to go. Okay, you use this pattern, you use this process, and I promise you, you will have a machine that will last as long as it's supposed to last. And that's really what you're looking at. And again, those that torque then being balanced is, again, something that you can just set in bed at night and realize I did this to the best of my ability and I have peace of mind knowing it was done correctly. The other thing a little tidbit of knowledge I want to give you guys, when you're assembling your machine, and I did a video about a week ago on, or maybe even 2 weeks ago, on troubleshooting your CNC like a pro, and I showed you guys how to create a Excel document to use to actually troubleshoot your CNC. Well, when you're building your CNC, I stated in the video, I'm just going to reiterate a little bit, you should always have that document ready because you want to always date and time your assemblies. And why I say date and time, I know it sounds technical. If you date and time everything and list your torque on each component a week or 2 or 3 later after you said, hey, you know, I'm going to do a PM on the machine, which stands for preventative maintenance, you can go back and measure the torque and see if it's changed. If it hasn't changed, hey, you know you did your job right. You know, salute yourself, go through, actually go back into your document, say I don't need to do anything, everything looks good. If you do find any slop or any, you know, something that needs adjustment, you already know that, okay, this was done on this date, it didn't hold, I need to look at what's going on with the system, or did I do everything to the best of my ability? Maybe I should clean the bolts again and re-Loctite them, whatever you need to go over to make sure the process was done correctly the first time. Once again, the more precise you are with this, the more precise that robot will be in either providing you, you know, more learning knowledge to accelerate the hobby and hopefully step into a business, or if you guys are doing a business already, you should be following these procedures immediately. Because I'm telling you now, the more you have these procedures in line, your products will follow. Remember one thing. The machine is what dictates the product. The more anal you are about being adamant about producing precision when it comes to fabricating the machine, you're going to get that same anal retentiveness, so to speak, as far as your products when you're done. You will be proud to see what's done, and that's, I cannot emphasize enough, it's following these processes, and they're not, you know, again, there's no videos I've seen on this for CNC yet. No other machine requires this kind of attention to detail I've been around other than CNCs, because they incorporate so much. You're dealing with electrical, you're dealing with mechanics, you're dealing with motion, torque. We have everything in a nutshell with a CNC. Following processes make things much easier, and I guarantee you using these methods will accelerate your learning on everything. So once again, we now know how to tighten bolts, how to go through and do this systematically. Again, if you have a 2-bolt process, we covered 4, we covered 3. If you have a 2-bolt process, it's very simple. Once again, always hand snug, bottom it out. Once it's bottomed out by hand, and when I say by hand, guys, let's use common sense. Certain times, bolts can get stuck. You can use a little oil. If you're using Loctite, of course, you're not going to be using oil. So if the bolt does get a little stuck, you can use a hand tool to get it down. You will not be torquing with the hand tool. You're just looking to bottom it out on the back of whatever mount we're going with. That's what we're looking at doing. So again, use common sense. If you have to use a hand tool just to get it to actually reach the bottom of the mount, do that. Once again, as soon as it does reach it, you stop. Okay, that's the easiest way to go through, and final torquing will be done when all screws, whether it be 1, 2, 3, or 4, are bottomed out on whatever we're mounting, and then you'll go through and torque everything. Now, that being said, if you have a chassis and you're doing 4 corner points on the chassis, I recommend torquing them each using this pattern. 1, 2, 3, 4. Let's say this box represents your CNC chassis, and you have a corner here, corner, corner. You're going to want to screw down, again, bottom out to 1, by hand, like we said, bottom it out. Then you're going to come over to 2, bottom it out, by hand, 3, and 4. Once that's all done, you will go back and then torque. 1, then 2, then 3, then 4, and you will be set. Again, always use that method. If you use that method, you're really doing your best to balance out all of that torque and stress on whatever you're mounting. Okay, whether it be assembling the chassis, we never want to pull the chassis out. A lot of guys I've seen, believe it or not, mounting their spindle mounts after tramming them, and they use too much torque on the spindle mount, and all of a sudden, you know, whatever they've used the shim stock behind there, they've pulled it out. And again, you're only dealing with thousandths usually. So I mean, if you snug it down too much, you're going to knock her out of calibration. You got to do the whole thing over again. It's a PIA to keep it, mildly. So rather than create frustration and do things inaccurately, get yourself a good torque wrench, a torque screwdriver. They're available on eBay. They're relatively cheap. Again, you will be using that instrument more and more. I love using that type of instrument. If you do any other work, I work on cars a lot. I use it all the time. I mean, you never have to worry about stripping bolts. You never have to worry about over-tightening bolts, and everything is evenly distributed, especially as softer substrates. Stepper motor mounts, if you look at them, they're only a couple millimeters in thickness. I mean, you're really dealing with the mechanics of the machine in terms of not a lot of strength is required to hold that motor to the chassis, especially when you're dealing with 4 bolts. It's no different than the wheel lug nuts on your car. You don't need an inordinate amount of torque to really hold that wheel on. You're looking for balanced torque. You want even torque all the way around that really accelerates and creates that synergistic effect of holding everything on evenly. That's what we're looking for. So always remember that as you build your chassis, we're always going for precision. Precision's not just only when the machine's on and you're trying to cut. Precision should be from the time that first bolt meets that chassis. Deal with it that way. I have a lot of guys that are now buying chassis overseas, and with good reason. Aluminum is aluminum. If you're buying a chassis overseas, my recommendation is follow this process right from the start. I don't care how big it is. I don't care how small it is. I don't care if you own a Bridgeport. This process on any machine will keep you out of trouble and have you doing everything right. Now, of course, common sense prevails. If your machine is full scale, 12 to 14 inch-pounds may not be enough. So again, use common sense based on the size of the actual machine you're working on. However, for, I would say, the 4 to 6 foot models, 12 to 14 inch-pounds, when you're mounting steppers or building the chassis in just normal fabrication modes, you're going to be fine with that kind of torque. So I would go with that. And again, best judgment. As long as you're measuring and you're happy with the torque and you've done everything right, Loctite is an amazing substrate when added to screws, especially when it's done properly. I have a lot of guys that have talked to me, and I've read a lot of things. I learned, again, from one of the best machinists I know in my area, and one of the things about Loctite, you have to make sure your bolts are clean of all oil for it to really do its job. The cleaner that bolt is of oil, then you can rest assured that bond is going to be amazing. And don't be afraid of throwing some throwing some acetone in the holes either. Let that oil penetrate and remove as much oil out of all of those holes as possible so that you're getting his bond as strong as possible. That's really what we're looking to do. It's that nylon type additive that it becomes is just amazing. It's really amazing when done properly. So again, we're not looking at just sheer manpower torque. We're looking at overall strength in the chemicals that we're using to formulate a bond between the metals and the nylon to expand in the hole, and that's really where you're going to get your tension from to hold everything together. That's what we're looking for. So once again, just to reiterate, you guys now know the proper mounting methods. And again, if you're doing home switches, you're going to adjust the torque. And when I say adjust the torque, you're not going to use anywhere near close to that. You don't need that. Okay, but the big thing here, make it applicable to what you're doing. Follow this principle. If you're using a 440 screw to actually mount to your chassis the home switches, use Loctite. Again, reduce the torque down, maybe 2 to 3 inch-pounds. You do not need a lot of torque for them. Okay, again, you're using Loctite, you're doing everything right now, you don't have to worry about that. If you do this process from the beginning and practice it, I promise it becomes fast. You'll have everything out. You'll have your acetone laid out. You'll have your chassis laid out, hopefully in a nice environment. And you want to be able to concentrate and really follow the patterns of doing everything, and I promise you'll be good. Another practice I like doing, if this was a chassis and I was assembling it, I always like to mark with masking tape where I've started from and what I did. So if I hand tighten down this screw, I might make a mark on there that says hand tightened, and then go to 2. This way I always know where I am in the assembly, because you guys are going to realize the more you work on your machine, it gets tedious to remember, did I do this? Did I not do this? I always like to keep little notes, because those little notes will go back, and anything to refresh your memory to make you save time and saying, okay, I did this right. I remember I did this. Look, I left a note. It's going to help you tremendously tremendously. And once again, document everything. Don't be lazy. Lazy people finish last. I'm just telling you. Document everything. You know, you're spending all this time and money to build a robot. Do it right. I promise you it will be the most rewarding project, or one of the most rewarding projects you ever do, especially when you get that finished good and you're like, wow, I built that. You know, I mean, it's just an awe-inspiring experience to really sit there and see a machine do this that you made, knowing that you took the time, you did it right, and you'll get the quality that you're expecting. So please do that. Document everything, date it, put down the torque, put down any adjustments you make. If you started with 12 to 14 inch-pounds and 2 weeks later you realize it's off a little bit, maybe it's down to 10, what do you want to do? You know, you can analyze the situation. Should I just pull the bolt, re-Loctite it after I clean it again and do all that? You could. You could definitely do that. You know, whatever you feel you want to do, I would definitely document. And whatever changes you make, let's say you do that and you decide to pull the bolts, re-Loctite them all, re-torque them down, and redate it. You want to let yourself know in that same troubleshooting spreadsheet, you want to let yourself know, hey, I did this on this date. Okay, I want to test this and see if this held up. This way you just learned something. I mean, the whole idea of trial and error is documentation of trial and error. Now you're engineering. That's the difference. Engineers document everything. Scientists document everything so that they know where they started and stopped. That's what you want to do. Again, that's what Fortune 500 companies do. That's how they learn from their mistakes, and that's how they become the production monsters that they are. We can use the same processes as long as we think in terms of our machine and scalability. And that's what I'm trying to do with you guys. So I hope this video was good. I want to finish this video by, just now that we've talked about precision and doing things precisely, I personally have a client. His name is Nate. Nate and I have been working on getting his machine set up, and we've been discussing some things. He bought a package from me a while back, and he's just now messaged me about finalizing, doing some processing as far as calibration on his machine. And he wrote to me, Vince, I'm spending some time calibrating the machine today. So far, I'm off 1/1000 over a 12-inch span using a dial indicator. Guys, using that process that I discussed in my calibration video, if you haven't seen it, I seriously suggest you check it out. Even if you haven't bought your CNC yet, it's great information to know. Being off 1/1000 of an inch over 12 inches for most projects, you're going to be fine. I mean, if you're doing woodworking, most guys are going to be way happy with that. I mean, that's pretty decent. The big thing here is, and I can't emphasize this enough, he's saying he's off 1/1000 of an inch over 12 inches. Okay, where you see a lot of the videos being done online about calibration, they're starting at an inch. You want to get that to go as long over that machine as possible, because here's the thing. Let's say his machine was 12 inches. I'm just reiterating some basics from that other video. Hopefully you guys will watch that. If his machine was off an inch and he only measured an inch and his machine was 12 inches wide, by the time he's off 1/1000, okay, if he's off 1/1000 of an inch per inch over a 12-inch span, he'd be off by 12 thousandths by the time he reaches the end of the machine. So again, that's what you have to think of in terms of relativeness when you're looking at distance. If you're measuring, you always want to measure as close to the end points of the machine as possible, so that you know your machine, the longer you run it, if you're doing a wide piece of substrate or you're actually cutting materials out, nesting parts and trying to get as many on that sheet as possible, you want to make sure that where it's closest to the spindle in the beginning of the Z movement, it's going to be as accurate as it is as close to the end of the machine's access point on X and Y based on the span of the machine. So once again, that may sound confusing. Watch the video that I created on actual calibration. It will explain a lot to you, and I'm really proud of what he's done. As a matter of fact, he's even shown in a video the process of what he's done, and I'll show it to you right here. I'm just going to open it up real quick. Let's see if we can. Here we go. And you can see, this video is done on his phone. You can see right here with the way he actually mounted the dial indicator. Now this dial indicator is only 1/1000 of an inch graduation. If he went to a test dial indicator with higher resolution, he could probably even get this tuned even closer than that. Everything you hear in the background is my equipment. Okay, his chassis, he actually he bought a chassis outright, and he fabricated then his equipment, his controller, using all of my equipment. So what you hear is my motors in the background. You see everything now in conjunction, and I'm going to play the video now, let you see it. You can see how slow he's going. Again, the jog speed is perfect. You're not looking to engage anything fast. We're looking at accuracy here. And to me, I hope, if anything you guys get from this, watching a video like this is where I really am excited about CNC, because this accuracy that he's hitting is pretty amazing. You can see he's got the feeler block at the end, and you can see exactly he used the bar as a measurement plate, and that's what actually brought that up. And again, the process he did correctly, and when you do it correctly and you take your time, that's what you get. So once again, guys, if you have any questions, my name is Vince. You can message me through eDealers Direct on eBay, or you can message me through YouTube, whichever is easier for you. If you looking at building a system, I'm always available to be contacted. I do offer personal support. I believe in phone calls. I like old school methods. Call me crazy, but that's the way I think things should be done. So hopefully you guys got everything you needed out of this. I plan on doing some more videos. Stay tuned. Probably next week or so I should be back online. Take care.